Caros colegas engenheiros e amigos, é uma honra e um prazer ter a oportunidade de transmitir esta mensagem por ocasião da comemoração da 4ª edição do Dia Mundial da Engenharia para o Desenvolvimento Sustentável da UNESCO. A programação deste dia foi uma das conquistas mais significativas da WFEO, a Federação Mundial das Organizações de Engenharia, e quero enfatizar o quanto ela é importante para nós e que é um claro e significativo reconhecimento da nossa parceria de 50 anos com a UNESCO. Mas vai muito além do reconhecimento simbólico. No contexto das 2 últimas décadas, as Nações Unidas e as suas agências analisaram corretamente o que está em jogo na adaptação à crise climática e ambiental, tanto para mitigar os seus efeitos, como para projetar novos modelos industriais, económicos e sociais que permitam um desenvolvimento sustentável. Sustentabilidade significa entender melhor o impacto das nossas atividades produtivas e modos de vida e criar as tecnologias, processos e infraestruturas que os tornem possíveis. Nada disso é concebível nem viável sem colocar os engenheiros no centro de tal projeto. Foram necessários muitos esforços de promoção nos últimos anos para colocar esta ideia na agenda das instituições de âmbito global. Mas isso está a acontecer agora e esse é o verdadeiro significado deste dia. O Dia Mundial da Engenharia é uma celebração da contribuição crucial da profissão de engenheiro para construir sistemas e comunidades resilientes e melhorar o bem-estar de todos, sem deixar ninguém para trás. É também uma ótima oportunidade para as instituições profissionais de engenheiros mostrarem exemplos práticos de como os seus membros fazem essa diferença em benefício das suas cidades, países e regiões. A engenharia para o desenvolvimento sustentável é especialmente crítica nos países em desenvolvimento para mitigar os efeitos das alterações climáticas, reduzir a pobreza e projetar infraestruturas e modelos relevantes de desenvolvimento. Para alcançar a capacitação nesses países, é essencial elevar e harmonizar os padrões de ensino da engenharia. Isso é crucial para alcançar uma das recomendações mais importantes do relatório da engenharia da UNESCO, para formar mais engenheiros com as competências adequadas. Também é essencial estimular a energia e a criatividade dos engenheiros mais jovens para inventar soluções tecnológicas para o futuro. É por isso que este ano o Dia Mundial da Engenharia tem como tema Inovação em Engenharia para um mundo mais resiliente. A sua principal mensagem é criar uma oportunidade para celebrar a engenharia e o contributo do trabalho inovador e responsável dos engenheiros para um mundo melhor e sustentável. Este objetivo é uma questão estratégica para a WFEO e um aspecto fundamental das nossas contribuições para as comemorações do Dia Mundial da Engenharia, principalmente através do hackathon de estudantes internacionais que estamos a organizar pelo 2º ano. Esperamos que muitos professores e estudantes de engenharia no seu país tenham participado nesta competição. Caros membros nacionais e internacionais da WFEO, eu espero que aproveitem a vossa própria celebração do Dia Mundial da Engenharia e convido-vos também a assistir ao vivo ou em replay o streaming de eventos em destaque que será realizado este ano novamente nos sites oficiais da WFEO. Desejo-vos tudo bom em todos os vossos projetos e atividades este ano e encorajo todos os membros nacionais e internacionais a envolverem-se cada vez mais nas atividades da WFEO no futuro. Existem muitas oportunidades para todos conseguirem grandes resultados, participando nos nossos comitês técnicos e de políticas, nos nossos órgãos de governo, representando a nossa visão e competência técnica e científica junto das agências das Nações Unidas. Convidamos a comunidade científica e tecnológica a celebrar connosco o Dia Mundial da Engenharia e a trabalhar coletivamente para um futuro mais sustentável para o benefício da humanidade e do ambiente.
The Higher Education Partnerships for Sub-Saharan Africa have been going for some years now, and it's a program that encourages interaction between academia and industry for engineering education to try and improve the relevance and the skills of engineering graduates. We've been funding 70 universities across Africa through a hub and spoke model where we have hubs in 9 sub-Saharan African countries and spoke universities feeding out from those hubs.
It's important to work with the universities in other countries and also even within Uganda so that the benefits from the project are not just for Makerere University, but they are also for those other universities and countries.
When the students come in, they know a lot of theory, but by the time they leave, they've really appreciated what is practically done on the ground.
The Royal Academy of Engineering UK has been supporting us through support of our academia-industry collaboration. It's very important that students are oriented to the actual production processes, culture of working, and most importantly, the rules and regulations that govern production in a factory. So that once they have that during their training, they will have no difficulties adapting when they get employed into the industries.
It's very exciting to see students who they now work together in teams, they will go to the industry and participate, and then at the end of the training period, you see people who are productive and they go out there and do many things.
We are a team that's looking at exploring water recycling as a solution to water use inefficiency, which is a crisis globally. So we decided to set up a system that consists of a constructed wetland right here. Water from the kitchen, which we call grey water, is directed to our system, treated efficiently, and is to be released into a garden to illustrate the reuse potential. Supported by the Royal Academy of Engineering, problem-based learning has helped us to concentrate on the problem and develop practical solutions for it.
Knowledge is a partner with the University of Namibia under the HubSub project. Through this program, Knowledge took on staff and students for training and exposure to the industry practices.
With the equipment and the books we've gotten from the HubSub project, they can compete to any student in any foreign university, be it in the UK, even in the US. Because we're currently using the same textbook, they are using the same kind of equipment. Even engine diagnostics, they are now seeing the physical equipment. The interest in the course has already tripled since we got the HEPSA grant.
So we've seen quite a lot of change as a result of this program. Clearly, much more exchange and dialogue between industry and academia, but also a much greater vitality in the student activities within the universities, as they really are much more motivated to build their skills for really making a difference within their country, within their region and beyond.
Engineering innovation for a more resilient world has a particular meaning to both engineers and engineers in New Zealand. It is how do we do engineering in the context of a world where there are greater stresses out there. There are stresses from climate change, there are stresses from our economy, and there's this constant desire to make things that last longer, perform better, have a reduced impact on the environment, and is better for our society. Engineering New Zealand, Te Aorangaho, is challenging engineers to be bold and creative in mitigating, transitioning and adapting to climate change for a reimagined and resilient future. To be good engineers as we head to 2030, we have to embrace a much broader range of cultures, and we have to take into account more than just human beings. We have to achieve great things in engineering, but which benefit the environment, in New Zealand benefit the Māori culture, and serve everyone. Engineers are naturally innovative. They love creating new things. In Engineering New Zealand, we are trying to encourage more people to become engineers. So we have a wonderful program called the Wonder Project, and it's all about getting kids excited and interested about STEM subjects. And the whole aim of this is to generate excitement, show people that creating things is fun. We also work very closely with the universities, and there is a real focus on things like understanding of the benefits of diversity and inclusion, understanding sustainability, understanding the social economic and environmental context of engineering and understanding the need for cultural linkages. Wellington has recently seen the launch of a fully electric ferry. It was done in conjunction with local iwi. It's better for the environment, obviously, because it uses electrical power. It also has much lower weight, and it's slightly faster than the old diesel-powered ferry and has slightly more capacity. So that's a really good example of engineering that is better for people, better for the environment, and really cool engineering. A big happy World Engineering Day to you all, wherever you are. Ngā mihi nui, kia koutou katoa.
Dear colleagues, friends, partners, associates, and members of the engineering family, as well as the entire global community, let me join the President and other leaders in WFEO in welcoming you to the 2023 and 4th World Engineering Day, in which the WFEO is celebrating in the ancient and beautiful city of Madrid, Spain. Let me use this opportunity to congratulate ourselves for making this day a reality and for making it more eventful than the years as the years go by. Normally, engineers are not very much outspoken in their communities and their country. So this day gives us the avenue to showcase our achievements, our successes, as well as our challenges to ourselves and to the general public. It is very important for engineers to learn how to blow their own trumpets, otherwise nobody will know the achievements they are making as the society progresses. The Spanish Institution of Engineers deserves a lot of appreciation for hosting this year's World Engineering Day, and also for choosing the most appropriate theme for this conference, Engineering the Cities of the Future. It cannot come at a better time than now. We have witnessed in recent times floods in Kentucky, United States of America, in Khyber Pakhtunkhwa in Pakistan, Assam, Bihar, and Maharashtra in India. In Africa, about 20 out of the 54 countries have witnessed severe floods which affected more than 8.2 million people. In Nigeria, my country, 34 out of the 36 states were affected by flood, causing the death of about 600 people and displacing about 8,200 houses. Of greatest strategy globally is the earthquake that happened in Turkey and Syria, which has claimed more than 46,400 lives so far. Let me also join the President in commiserating with the people of Syria and Turkey over this disaster. All the above challenges point to the need for engineers to come together to develop ways and means of mitigating these types of catastrophes and challenges to be happening in the future. These are the issues to be discussed and articulated at this year's World Engineering Day. We at WFEO look forward to the outcome of this particular conference, as well as all the other conferences and events that are happening during this World Engineering Day, so that we come up with a compendium which we are going to share to all our national and international members for their use and benefit. I wish everyone a very happy World Engineering Day 2023. Thank you.
One person's trash is an engineer's treasure. Engineering, making life happen.
At PDV Consultants, we work on process and manufacturing projects in the dairy industry. Advice that I would give to students currently looking for a graduate role is to not be afraid to apply for internships rather than graduate positions, because internships are a really good opportunity to give you an idea of what the job's actually going to be like, and it's also an opportunity to make good connections in the industry as well.
My greatest achievement so far, in my opinion, is the research that I've developed. So I've come across new systems which I can help to cultivate microalgae in a more higher efficient manner. And I also developed this novel multi-phase partitioning technique, which has been proven to be able to extract not only one product, but multiple products in one single processing system.
I work in a range of different aspects of wastewater and clean water design. My advice to a student doing an application is think about your skill sets outside of academia. If, for example, you were part of a sports team, talk about teamwork and your commitment to that team.
Yeah, my best advice to students looking for a graduate role is to first understand yourself. What drives you, what motivates you, what are you good at? And when you understand this, then you look as well at the opportunities out there, what in industry, and you can see what kind of matches.
In my role, I lead a team of approximately 70 people based in 8 different countries across Europe, and we set the reliability strategy, the maintenance best practices, and general knowledge sharing across Amazon to ensure that all our equipment runs reliably and smoothly. I've had many mentors throughout my career, and each time they've been instrumental in giving me the encouragement and support to move from one role to the next, or for helping me develop my thinking so that I can continue to grow.
The best advice I had that helped me transition into a senior leadership role was actually about being not afraid to jump in and take up opportunities that might be a little bit outside my comfort zone. And in doing so, learning new things, but also seeking advice from experts and specialists in the field.
Hello and welcome to this showcase of Serving Society, a special programme from the Institution of Chemical Engineers and ITN Productions, celebrating IChemE's centenary.
From making everyday household items safe to creating medicines that save millions of lives, we take for granted the enormous contribution that chemical engineers have made to our world, especially over the last 100 years.
We've served society well for over 100 years in terms of providing the materials and the energy and the water and all of the sort of the life-sustaining items that allow everybody to do what they want to do every day.
The Institution of Chemical Engineers was established in 1922 and supported the industry as it kept pace with the world's needs, especially in health. Chemical engineers have been instrumental in helping save and improve lives, scaling up mass production of essential therapeutics. Today, this ability to take a basic element and then produce it for the masses helped in the daunting task of delivering COVID-19 vaccines globally. Biochemical engineers working with University College London were primed to scale up production of the Oxford AstraZeneca vaccine from day one. They were instrumental in its development and delivery.
It's understanding how you can translate a process that has been manufactured in one vessel type or configuration at one volume or scale to another vessel which is bigger, probably very different in terms of its configuration from the vessel that you used to develop the process in, but at the end have exactly the same product with the same critical quality attributes that needs to be given to a patient.
As you move to the later stages of the clinical trials, just before you get regulatory approval, you need to think then about the commercial manufacture of the vaccine. And that's where another one of our UCL graduates, Mark Proctor, came in. So Mark is a director of operations at one of the AstraZeneca manufacturing sites. And he basically put together the supply chain necessary to make all the vaccine.
Science has earned the gratitude of the world by coming to its aid to help manage COVID-19. Now iChemie is marking its centenary by identifying areas based on the UN Sustainable Development Goals where chemical engineers can help tackle other major challenges such as climate change and sustainability.
We're going to start off in February with sustainability in the environment, and we're going to launch a sustainability hub that will help members to improve the efficiency and optimise the processes that they're operating and really think about reducing footprints for carbon, CO2 and the like.
Climate change and sustainability are not separate issues. They're inextricably linked, and chemical engineers need to apply their system thinking to understand the whole picture, the relationship between the different components, and make sure there's not unintended consequences from any particular courses of action. More specifically, chemical engineers are working to drive energy and resource efficiency, to develop new and better renewable energy sources, to better store energy, be it through batteries or hydrogen or other means. They're working on waste, how to reuse it, how to reduce it, and how to dispose of it most appropriately. And finally, they're working on sustainable food and recognising the nexus between food, energy and water, and how all three of those need to be addressed in a sustainable manner.
At Recycling Technologies, solutions are already being developed to tackle one of the most urgent problems: what to do with waste plastic, most of which is not recycled or reused. The company has created patented technology to recycle plastic waste into feedstock for new plastic production.
In our area of the industry, we are indeed making an impact to a problem that we have today. I think plastic in the ocean is a reality, and we can see it and we can feel it. So young engineers have got the opportunity to come into our industry to have an impact, to develop solutions that would help a global problem.
Young engineers are bringing fresh thinking as they enter the industry, attracted by the thought of making a real difference.
There's very few other careers where you can really be at the forefront of that decision making and be able to have a hands-on impact in trying to solve these problems.
Andy Hemingway would agree. His degree in chemical engineering led him to the graduate training scheme at Wood plc, which he says provided the chance to experience a huge range of work environments that really affect how people live.
It's such a diverse career. Chemical engineers are involved in all aspects of changing the world. So, if you're sat there and you're thinking, how do I make a difference? How do I really change the world? Do chemical engineering, because you'll get the opportunity and you'll be able to.
Wood plc, a global leader in consulting and engineering across energy and the built environment, is going big in its efforts to reduce CO2 emissions. It's working on Humber Zero with other industry partners to provide innovative solutions in helping to retrofit this vast industrial complex with post-combustion capture to save millions of tonnes of CO2 each year.
We do need to make these first-of-a-kind type investments and really start to make big steps towards capturing carbon at scale and decarbonising industry in particular.
That gets us most of the way, but we still need to warm up the solution.
Students at Imperial College London are getting hands-on experience in learning how to tackle climate change via this carbon capture plant within the Department of Chemical Engineering.
Having loads of people with different backgrounds, people have different ideas and different inputs.
It will actually teach me a lot about just how is it that the carbon capture actually works, and it actually directs and correlates very nicely with just the green energy sector that I'm actually going into, and so I'm really excited to be doing this.
A holistic approach to experiments ensures that problems are not looked at in isolation. Here, sodium-ion batteries are powered by recycled carbon from waste.
We're stimulating a circular economy whereby instead of putting waste in landfills, which generates methane and contributes to global warming, we're taking biomass, we're extracting valuable components from it and using materials. So we manufacture this into very high-end advanced functional materials.
Waste from this nickel refinery in South Wales is now considered a valuable commodity. Algae is being grown from its CO2 effluent. Its inbuilt carbon capture helps it to photosynthesize. It can then be used for commercial purposes.
For every kilogram of algae that we produce, we capture roughly 2 kilograms of CO2. So as you can see, this is a great way to mitigate climate change, but also capture and reuse that carbon. And one of the things we want to do is integrate this process further to work with local agriculture and take nitrates and phosphates from animal waste and anaerobic digestion wastes and integrate those into this process as well, and therefore we'll generate a true circular economy that generates value in terms of the product portfolio that we can achieve from the algae themselves.
Valley Europe are working with Swansea University on ways to produce hydrogen using water and renewable energy instead of natural gas. Chemical engineers ensure the process is both scalable and risk-free.
It needs to have a certain readiness level to allow us to invest as a company. So it is crucial that this work is progressed with industry so that we can have that real-world results. Working in the collaboration with the university gives a real good platform to give us real-world results that we can then use to justify capital expenditure and investment.
University research is really driving change in chemical engineering. Students believe they are uniquely placed to understand how the world works due to the connection with different industries.
I think the difference with chemical engineering is that it's such a broader picture. You're not just doing the maths, you're not just doing the science. Actually, there's an interconnection with many different industries. You work with the chemists, you work with the people who are scaling up, so the mechanical engineers, the people who are doing that kind of work, and you work directly with the society as well. So yeah.
We teach the students the new technologies, the policy development, the economic aspects, the social awareness, the whole system thinking, alongside the technology development. So we don't want them only to be the future engineers, we want them to be the engineering leaders that can tackle the most pressing challenges and can drive the great transition happening in the chemical industry.
As well as regularly evolving its curriculum to keep up in areas like the circular economy and the wider societal context, Loughborough University also uses digital technology to simulate real-world learning.
I'm looking at creating a digital version of what's going on in reality. So in a sense, it's a bit like a video game. Video game, you might be running around. In real life, you might be running around. And you can simulate this between the two. With a digital twin of the pharmaceutical process, I'm working towards making a process which digitally runs the exact same as it would in real life.
The 2050 drive to net zero has fundamentally shifted the way of working in the chemical industry, and we need to create new jobs that do not exist even today to tackle some of the most pressing challenges to decarbonize our energy and industry, and that's our chemical engineering's job.
Work to decarbonise the industry is happening at the University of Manchester's Department of Engineering, acknowledging that how we live is a product of chemical engineering, but admitting that we face a huge challenge to reduce the footprint of all these technologies.
We're looking at ways of finding alternatives to petrochemicals, so rather than using crude oil as the raw material, as the starting point. We're looking at using fermentation processes, so natural processes that we use to make things like beer.
The ambition for everyone at Manchester Chemical Engineering is to ensure that their pioneering work gets out of the lab and into production. To help achieve that, Dr. Winterburn has co-founded the company Hollyfirm.
What Hollyfirm is doing, their driving mission is bringing kind of biosurfactants to market, so we can use those to replace petrochemical surfactants. And surfactants are the ingredient that are in all our cleaning and personal care products. They give cleaning action, so we all use surfactants every day.
Spinning out your own company is one way to generate sort of commercial impact. The other way is to work with existing businesses. If you work with a large corporate that has got huge resource behind them, then that can really expedite the translation of your research.
It's that mix of ambition and collaboration with business that's attracting the next generation of chemical engineers.
Well, you see all these big plants and factories and you wonder how can somebody control all this. That's what inspired me to take chemical engineering.
Studying chemical engineering at the University of Nottingham, Malaysia, prepared Sadaf Hamati for her job as a senior business developer at a company in the Netherlands which helps car manufacturers create high-performance sustainable tyres.
The chemical engineering course was very well designed and well balanced in terms of teaching you all the technical and engineering courses, but in the same time teaching you the transferable skills. So you're giving a lot of group and courseworks, that group projects where you and your teammate need to work together. So this helps with your developing your communication skills. You're working with broad range of peers and students that come from different backgrounds, helps with project management, develops your leadership skills. And these are the things that I'm still using on my everyday life.
The courses here are in high demand, currently attracting 5,000 students from nearly 90 countries.
In Nottingham, Malaysia, we have 20 academic colleagues who nurture our undergraduates and postgraduate students towards their career preparation. So these academic colleagues have their expertise in food processing, environmental protection, as well as process system engineering. All these area of research expertise enable the students to undergo their training during undergraduates and postgraduates with us, so that those training ground prepare the students for their career in the future.
The university has so far produced more than 1,500 successful graduates, now established in a diverse range of careers, taking with them groundbreaking ideas covering environmental impact, climate change and sustainability.
V1 is a volumetric flow rate going into the process.
Nuclear power will be required to play a pivotal role if the world is to meet its sustainable development goals. Nuclear Graduates is a graduate development programme led by the people and skills organisation Energous in partnership with other nuclear sector employers, and is designed to attract a diverse range of talent.
Nuclear energy is a low carbon form of energy and is expected to gradually replace fossil fuels as a main source of energy alongside renewables. So there's a lot of interest and a lot of growth in the sector.
Energous works really closely with the nuclear sector to understand their skills needs. And the Nuclear Graduates Programme enables our partner organisations to recruit talented young professionals and provide them with a wide variety of opportunities that enable them to grow and understand the sector in its broadest possible context.
The programme has won the IChemE Global Award for Training and Development and is one of the most comprehensive the sector has ever seen. Nuclear graduates undertake 3 secondments with industry-leading organisations during the 2-year programme and can design their own bespoke professional development.
It gives you like a broad range of opportunities. The programme not only important on-the-job responsibility and experience and formal training, but also this kind of community sort of engagement as well. So that's kind of this broad aspect of the programme I'm really enjoying.
Chemical companies have more of a focus on the environment, social responsibility and governance than ever before. But Scott Barder's values of working ethically have been at the heart of everything it's done for the last 100 years. The difference here is that the workforce own the company.
It makes a range of polymer-based products for composites, for adhesives and for functional applications such as personal care. The founders, Ernest Barder and Dora Scott, that they were Quakers. So when they set the company up, they set it up with some real fundamental values. And that was really about doing no harm to the environment, but it was also doing social good and treating everybody equally.
Employees have created a vision for 2036 and have set up an Operation Sustainability Committee to improve emissions and energy usage over its 6 manufacturing sites.
The primary objective of that committee is to help Scott Bader achieve the 60% target in Scope 1 and 2 emissions. Mapping our consumption is a logical first step, especially when it comes to energy. And then moving on from there, the sites have to explore the different improvement options, and then they're responsible for creating an action plan that's specific to their site.
The next stage for us is really to start improving the sustainability of our own products themselves, be that based on biological raw materials, be that recyclable. So we have a significant research and development activity today, really looking at how we develop those materials for the future.
The global engineering project management consultancy Atkins is working hard to maintain a sustainability drive across many sectors, including energy, transportation and water. Water is facing a challenging time due to its energy consumption.
Well, the water sector uses a lot of energy. Up to 3% of the UK's total energy consumption is in that sector. And that's mostly in pumping and aeration to ensure safe drinking water to customers and protect the environment. Population growth and climate change and environmental protection mean that we're moving water further and further, particularly to the water-stressed southeast. So really the key challenge is to meet the needs of society and environmental protection while working towards a net zero.
Atkins is supporting a route map to net zero for the sector in alignment with guidance published by both ICME and Water UK.
We established our engineering net zero initiative, and that provides a framework for our engineers, scientists and project managers to support our clients on their journey towards net zero and following that Water UK route map. It represents thought leadership, carbon accounting and reduction throughout the asset life cycle, from strategy, design, construction, also through operation and end of asset life recycling.
World leaders in CO2 reduction, KBC, are also supporting their clients in their efforts to address climate change and sustainability.
It can now very accurately predict the carbon intensity of fuels, the carbon intensity of products, how we make the fuels, how we can then begin to remove carbon and substitute hydrogen or synthetic fuels or e-fuels as they're called.
We've got these skills, experience, software, whether it's a refinery producing transport fuels, a petrochemical site producing chemicals, somebody producing building materials. We're helping them to reduce the amount of energy that they use. Reduction in energy means reduction in carbon dioxide output.
The company believes decarbonisation is no longer a choice, but a global imperative that's driving industry change.
Due to the current environmental conscience, our clients are changing the way they produce chemicals and fuels, and on top of that, reducing energy consumption drives competitors to also reduce energy consumption.
What most excites me is that we can have a real-world impact on the energy transition.
And we can really make a difference as chemical engineers in the world to become a more sustainable society.
Not only do chemical engineers have to concern themselves with reducing the environmental impact of their work, but they also have to ensure that the materials used for everyday items are safe. To help them keep up with constantly changing regulation, Mike Penman set up Penman Consulting.
Every single chemical that's put onto the market or manufactured is subject to chemical regulation. Nowadays, you have to provide a large amount of information to regulatory authorities and prove that the chemical is safe in its use.
They've developed a program that brings together all the information a company needs in one place. It's called Active Steward. It gives updates to make sure chemicals comply with the latest regulations.
We combine the science and the technology together, which is very rare to do. And this in turn will help us overcome next generation issues that the chemical industry are bound to face.
And as the world takes a more sustainable path, more companies are asking for help to understand and comply with new ways of working.
Indeed, as we move towards more circular economies, this comes with increased customer demands, regulatory requirements, but also the industry will play a critical role in actually meeting the ambitions of the European Green Deal, the Chemical Strategy for Sustainability, or the UN Sustainable Development Goals. Industry is in transition, incorporating all these new concepts into each and every step of the value chain. We help them navigate through that, manage their sustainable strategies with our next generation product stewardship.
Global safety and security company DEKRA are mindful of their sustainability obligations as they provide technical safety and human reliability solutions to industrial operators to reduce the risk of serious accidents.
Being a process safety engineer involves ensuring clients manufacture their products without causing harm to people or the environment or any neighbouring facilities. Firstly, we identify the hazards, either by the material or from the process itself, and then we assess the risks. And finally, we introduce barriers, either preventative or protective, to stop an adverse event from occurring.
I do a multitude of safety testing, such as the adiabatic duocalorimetry, which is a key method that we use to test whether or not processes are safe or not.
Chemical engineers spend many hours in the laboratory assessing new processes developed by chemists to understand their potential hazards and simulating what could happen in a worst-case scenario.
The irony of what we do is that when we do our job really well, nothing happens. The company just carries on producing, but what we're dealing with is events that are extremely low probability, but extremely high consequence.
DEKRA is committed to putting human life at the forefront of everything they do while keeping an eye on new technologies.
Some people talk about the challenge to the future of work as a result of digital and technological change. But fundamentally, whatever happens in the technology space, you still need the human context. So looking at it, members will be increasingly involved in helping to deliver, optimize, and make more efficient all of the processes that serve society.
What will the world look like in the future? The aim is for a more sustainable way of manufacturing the products and services we need to lead healthy, fulfilling and meaningful lives. But how do we get there from today? Chemical engineers play a pivotal role in how we live. We work across every industry, right across the globe, linking sectors together, giving us the knowledge to lead and influence change. To help the world transition towards net zero by 2050, the UN has 17 sustainability goals. Each one impacts the other. For example, how do you sustainably feed 10 billion people by 2050? Natural resources are limited for food, energy, clean water and healthcare. So which one do we prioritise? Chemical engineers can enable a way to provide all of them by looking at the full picture, the whole system. Take the vision for the city of the future. It's projected that in 2050, every second car on the streets of the world could be electric, but it's not so simple. Electric cars will put a huge strain on the limited generation and supply of renewable energy. So maybe we use green hydrogen as a fuel, but the process requires a lot of water, and water is becoming more and more scarce in some parts of the world. The answer could be blue hydrogen as a transition. Yes, the process creates some carbon dioxide emissions. However, we now have technology to capture the CO2, and hopefully in the future, chemical engineers will enable the CO2 to be used as a sustainable feedstock, such as feeding algae for bioplastics. Looking at other fuel sources for our cars allows our limited renewable electricity capacity to be used elsewhere. For instance, using renewable energy in the chemicals industry instead of the methane produced as a byproduct allows the methane to be used for fertiliser production, helping us to grow more food without needing to extract even more gas from fossil fuel reserves. And that's just one example that illustrates how and why joined-up thinking by chemical engineers can have a significant impact. It's a worldwide challenge with no one single answer. Chemical engineers need to work with other engineers, scientists and policymakers, shaping education, research and innovation in an ethical and responsible way. Climate change, poverty, hunger. We have the power to solve some of society's biggest problems. to reimagine the world for everyone.
Hello, everyone. My name is Dr. Marlene Kanga. I was president of the World Federation of Engineering Organizations from 2017 to 2019. During my term as president, I led the proposal for the UNESCO member states to declare 4th March as World Engineering Day for Sustainable Development. This is our day to celebrate the work of engineers and the impact of engineering around the world. I hope that you will take the opportunity to celebrate and tell the community, your friends and your family about the wonderful work that you do and how much you enjoy it. Happy World Engineering Day.
Old gold mine. Engineers saw a golden opportunity to power our lives. Engineering, making life happen.
Der Beruf von Ingenieuren, der ist so in den Hintergrund treten. Ich merke das auch selber, wenn ich jemandem erzähle, ich bin Bauingenieurin, dann sagen die, du planst die Häuser. Dann sage ich, nicht ganz. Ich rechne, dass das Haus hebt, dass es statisch funktioniert und dieser Beruf ist einfach nicht bekannt. Und da wirklich mehr Fokus darauf zu setzen, dass wieder mehr junge Leute Lust haben, diesen Beruf zu studieren und Ingenieur zu werden, das erhoffe ich mir tatsächlich.
Ich sehe zwei Herausforderungen. Auf der einen Seite die Gesellschaft, nämlich die komplexe Technik verständlich zu machen. Die andere Seite ist Politik, damit man auch die richtigen Maßnahmen auf politischer Ebene kann durchsetzen kann.
Setzen Sie mal auf. Ich heiße Sie herzlich willkommen hier zum Ingenieursday Netzwerkanlass 2023.
Mir geht es natürlich um die Vernetzung hier und mir geht es auch darum, junge Nachwuchstalente anzusprechen und vielleicht kann ich sie sogar für eine Arbeit an der EMPA gewinnen. Und dann können uns die jungen, motivierten Personen helfen, nachhaltige Materialien und Technologien für eine nachhaltige Schweiz zu entwickeln.
Wir sind das mal im Verkehrshaus Luzern. Wir präsentieren dort vor allem Projekte aus dem Bereich Energie und Nachhaltigkeit, unter anderem mobile Solarpanels. Und es ist ganz eine wichtige Möglichkeit, Wissenschaftskommunikation zu betreiben an eine weitere Öffentlichkeit, an Jugendliche und ihre Eltern.
Wenn Frauen da mitwirken können, haben wir viel größeren Bedarf von der Gesellschaft abdeckt. Und darum finde ich es sehr wichtig, dass das Potenzial, die Ideen von Frauen mit eingebracht werden.
Die Teilnahme am Engineers Day ist für uns eine Investition in die Zukunft. Wir kennen all das Thema vom Personalmangel, Ingenieurenmangel. Da suchen wir immer wieder krampfhaft Leute. Und wir haben im Vorfeld einen Lauf gemacht von Schlieren auf Bern. Auch, dass wir mehr Präsenz auf die Berufsgattung geben, wo ich glaube, die Grundlage ist vom heutigen Dasein. So wie wir heute leben, könnten wir nicht ohne die ganzen Erfindungen und Entwicklungen von Ingenieuren und Ingenieurinnen.
The Indian Institute of Technology Bombay was set up in 1958 by the Prime Minister of India, Pandit Jawaharlal Nehru, as an elite institution to elevate and provide strategic technological advantage to the country. IIT Bombay was established with the cooperation and participation of UNESCO and the erstwhile government of USSR. IIT Bombay, situated in picturesque 550 acres with the Vihar and the Powai Lake on either side and green hills in and around. IIT Bombay is a fully residential campus housing the best research infrastructure, classrooms, hostels, sports and medical facilities. IIT Bombay brings together the best minds in their pursuit for excellence. Today the institute has about 5,600 undergraduate students, 3,700 postgraduate students, 3,700 PhD research scholars and 400 postdoctoral fellows. IIT Bombay has 28 academic units and 25 research centers with about 700 full-time faculty, 4 professors of practice, 70 adjunct and 50 visiting professors. The faculty at IIT Bombay work on fundamental experimental and theoretical challenges, as well as on development and translation of their research to create industrial and societal impact. Areas of teaching and research at IIT Bombay include all branches of engineering and technology, all areas of science, as well as economics, policy, and social sciences. Our faculty are internationally recognized as leaders in their respective fields. IIT Bombay has several academic and research programs that are aligned with the United Nations Sustainable Development Goals. Areas of focus in teaching and research include development of solutions for complex societal problems ranging from water access and quality, malnutrition, healthcare and clean energy, amongst others. For instance, the interdisciplinary program on climate studies has an internationally recognized research program focusing on climate science, climate adaptation and climate mitigation. IIT Bombay research has helped to significantly improve climate prediction models. IIT Bombay faculty have also been engaged in addressing problems related to energy transition, decarbonization, clean energy generation towards reducing environmental impact.
We impart education that transforms students into innovators, researchers, entrepreneurs, and leaders of tomorrow so that they can take care of real problems in the outside world. IIT Bombay's unparalleled research infrastructure, world-class faculty members, and unique opportunities and resources have placed us at the top of the table on the world stage.
In the last 5 years, IIT Bombay has received extramural funding of 1,376 crore rupees for its R&D activities. IIT Bombay has also been granted the status of Institute of Eminence by the Ministry of Education, whereby it has received about 430 crore rupees as grants. Out of this, 342 crore rupees have been earmarked for research infrastructure development.
IIT Bombay has transformed itself from being just an educational institution in the early years to a premier organization for research and development today. IIT Bombay's area of research are diversified. Along with conventional research areas like nanotechnology, solar energy, battery technology, sensors, healthcare and medical devices, etc., we have a strong focus on new areas of research like quantum computing, carbon capture and storage, drone technology, hydrogen and electric vehicles, blockchain, etc. Our R&D centers like Center of Excellence in Nanoelectronics, National Center for Photovoltaic Research and Education, Biomedical Engineering and Technology Innovation Center, these go hand in hand with new centers like National Center of Excellence in Carbon Capture and Utilization, the Koita Center for Digital Health, Center of Excellence in Oil, Gas and Energy, Center for Machine Intelligence and Data Science, C-Minds, to promote interdisciplinary research in cutting-edge technology. Our scientific contributions can easily be measured by the large number of publications and citations. The ever-increasing number of intellectual property applications, that is patents, copyrights, trademarks, design, has positioned us top innovators of this country. It ranks amongst the topmost centrally funded technical institutes in the country for its R&D, innovation and entrepreneurship efforts.
Centers of excellence such as National Center for Photovoltaic Research and Education, National Center for Excellence in Carbon Capture and Utilization, Center of Excellence in Oil, Gas and Energy, have been working collaboratively with the industry to develop efficient solutions in energy transition and mitigation of climate change effects, and the Policy Center has been working collaboratively with various national and international agencies towards developing scientific understanding that feeds into policy making. IIT Bombay faculty have also been working collaboratively with researchers in the medical domain towards facilitating affordable healthcare, and on ailments such as cancer, aging, and neurodegenerative diseases. Other areas of research at IIT Bombay that impact society include addressing malnutrition in children, and management of access and quality of water in rural and urban areas.
In keeping with the Prime Minister's Atmanirbhar Bharat mission, the focus of R&D at IIT Bombay is on providing sustainable technologies to startups and Indian companies. Various public-private partnership (PPP) projects between industries and IIT Bombay with government support has helped to convert technologies available in labs to deployable commercial products.
IIT Bombay has R&D collaborations with various universities and organizations across 40 plus countries of the world. Monash University, Australia and Washington University in St. Louis, USA have joined forces with IIT Bombay to create a unique joint venture research academy. We also have joint PhD program with top Taiwanese and other reputed universities, which provides unique opportunity for undertaking cutting-edge research to our students.
Since its inception, Indian Institute of Technology Bombay has worked towards providing technological and industrial self-sufficiency for a new nation. After 60 years, it has now evolved as a world leader in the field of engineering, education and research.
IIT Bombay has always received a very enthusiastic handshake from its alumni to promote several initiatives in R&D, infrastructure development and student wellness programs. Our industry partners have contributed to setting up of several centers of excellence in emerging fields, research laboratories and collaborative projects through donations, endowments and CSR grants. As IIT Bombay forges ahead along its strategic plan, we look to derive support from our alumni and the corporate world towards mutual growth and societal impact.
IIT Bombay has nurtured the entrepreneurship ecosystem with great care. Industry focus and collaboration and technology licensing are at the heart of the R&D.
IIT Bombay's Technology Business Incubator, the Society for Innovation and Entrepreneurship, SINE, is one of the earliest incubators in academia. It provides start-to-scale support for technology-based entrepreneurship and facilitates the conversion of research activity into entrepreneurial ventures.
SINE and IIT Bombay work together to promote entrepreneurs of tomorrow. Favorable terms of engagement for our incubators, funding support through various programs and grants at various stages, starting from fellowships, prototyping grants, seed funding, mentoring support, etc., have helped convert ideas to technologies that are driving the market today. Companies like IdeaForge, Atomberg, Sedemac Technologies, ImmunoAct are the examples of the startups who started their initial technology development within IIT Bombay, spun out their ventures for incubation at SINE, and now are market leaders in their respective business areas.
Many of our alumni hold senior corporate as well as academic positions and are recipients of prestigious national and international awards and are also success entrepreneurs.
IIT Bombay Research Park Foundation is an innovation hub promoting industry-academia collaboration. Our collaboration with clients and associates enables two-way flow of knowledge and resources.
At Technology Innovation Hub for IoT and IoE at IIT Bombay, the focus is to foster translational research and provide platforms for standardizing IoT applications. The R&D activities are currently targeting IoT solutions for agriculture, healthcare, education, defense, and industry verticals to support the Industry 4.0 transformation through multidisciplinary in-house R&D. We aim to emerge as a world leader in these technology solutions by connecting the world through IoT and making life simpler.
IIT Bombay's mission is to create an ambience in which new ideas and creativity flourish and from which research and scholarship and leaders and innovators of tomorrow emerge.
We'll continue to create tomorrow's leaders who are deeply rooted in science and technology and contributing to the societal goals of the country.